All right, so this is my presentation, Too Green, Too Clean. I'm going to talk pretty fast. I have a lot to get through. I'm going to be talking mainly about biodiesel and algae-based biodiesel. So what is biodiesel? It's a renewable, biodegradable fuel derived mostly from plant oils. So obviously fossil diesel is just crude oil. It's not renewable. So biodiesel is an alternative to that. It's renewable, and it has grown in popularity due to increasing concerns over climate change and the need for a sustainable energy resource. So there's two types of algae-based, there's two types of biodiesel, algae-based and crop-based, and there's different types of development status for each of them. I'm going to be talking only about algae-based because there's more promise with it. So algae-based, very efficient, but still in the research stage. It's not very cost-effective. It's about $20 per gallon, which is extremely high compared to crop-based, which is only about $4. And let's not ignore the fact that that's more than regular gases right now. But again, it's renewable energy. It will most likely be expensive. But then for algae-based, there's limited usage. It's only used in certain countries like the US or Japan, again, because it's in the research stage, and only in specific vehicles. What I mean by this is it's mainly used in the military for jet fuel because that's where you can put the most research into it. So then crop-based, it's not super efficient, but it's commonly used. Its main issue is it competes with farmland. So you have the issue of using that land for food or for fuel. But it's very cheap per gallon compared to algae-based, and there's global usage everywhere in like cars and trucks. So what is the idea behind biodiesel? We should first talk about a photobioreactor. Basically, you have the whole list there, but it just gives the best conditions for the algae to grow in. And I didn't draw my own image because I felt that this was pretty good. It shows how space effective it is. It kind of looks like a thylakoid with how it's like on each other. But yeah, again, it's very space effective. You can grow a lot in here. And the idea behind biofuel is that all biodiesel is based on the idea of photosynthesis, which is what makes it renewable. So the actual equation for this, for biodiesel, you have photosynthesis, which goes and makes glucose, and the glucose is used in cellular respiration, makes pyruvate, makes acetyl-CoA. Then that acetyl-CoA can turn into fatty acids and then eventually triglycerides. Again, a triglyceride has a glycerol head and 3 fatty acid tails. So you don't make ATP in this case, but you do make fats. So then how do we actually make the fuel? So we should talk about transesterification. It's just the equation is a fatty acid plus methanol turned into methyl ester, and that's your biodiesel plus glycerol. Glycerol isn't really important, but we should talk about what an ester is. An ester is an organic compound formed by acid and alcohol. Here's your acid, here's alcohol, and why use methanol? It's the smallest alcohol, so it's easier to do the reaction. And an ester, it's just a better way to have a fuel, and there's a reason why. So here's just a quick recap of what actually happened. So before this step, there's actually one more. You basically remove the algae from its growth medium. You can just do that with filtration. Then you get to this step. So you have to degrade the cell walls using enzymes, and there's other methods, but enzymes are the simplest. And then you want to dissolve the oils in something like ethanol, just so only the oils get dissolved and everything else is left. So then you can remove them. And then once it's just the dissolved oil, you can evaporate the ethanol, so then only the oil remains. Then you bring it to transesterification. So that's when you get this equation again. And then we can talk about carbon footprint. So it should be carbon neutral in theory, but what does it mean to be carbon neutral? You essentially have no carbon footprint. So is algae-based biodiesel carbon neutral? Yes. Why would it not be carbon neutral? So every biodiesel, every fuel in general just has some impurities, so it's never going to be 100% efficient. So although it will make CO2 upon combustion, it will never make just CO2. So an example of impurities would be glycerol. So this is the idea. So you have the combustion of the biodiesel. It then releases the CO2 after combustion, and then the CO2 is reused by the plants. So then what's the economic impact? Is algae-based biodiesel economically feasible? No. There's heavy infrastructure costs, biophotoreactors, nutrients, extraction materials. Is crop-based better? And in terms of economics, yes, but it competes with normal agriculture. So there's still economic issues with crop-based, not to mention that it's more expensive than regular fuel. So then there's the communication efforts. How to promote biodiesel. This is just in general for any renewable resource. Governments and NGOs, they use a lot of incentives and cost cuts because it's necessarily not going to be more efficient than regular fuel. So you have to have some incentives to actually use renewable resources. But for biodiesel specifically, there's imports from Europe, which have increased recently. The EU has made it cheaper, and because they support a renewable fuel heavily, and they made it friendlier to use. So this is just like a large backing from a big organization like the EU, which is known to prioritize climate change, makes it easier to promote stuff like biodiesel. So my analysis and suggestions: biodiesel, very environmentally friendly, crop-based is the most efficient, and algae-based has a lot of promise, but a lot of issues. So it's not necessarily more efficient than regular fuel, again, like I just said. which makes it even harder to upscale and promote. So my suggestions would be to just invest more in the research, make renewable resources a priority in the government, and then, like the EU did, and then mix biodiesel and normal diesel. This can just make it easier to promote. You're using something you've already used, like diesel, with just like an extra ingredient like biodiesel. So my plan of action, here it is in a nutshell. You have large-scale biophotoreactors. Here's a little Vin Diesel scale. Bunch of algae, genetically engineered algae for the most lipid production. You want to give it the best uh, reactants like sunlight, CO2, or sunlight, CO2, nutrients as possible. And then you want to automate the process. This is for cost cuts. Obviously, cost is an issue here, but you would do this in general. Then you want to mix the biodiesel and normal diesel, like I just said. Then invest in research, promote the product with large-scale policies like the EU, and then have worldwide cooperation. Eventually, this makes it cheaper, and it's just wide-scale usage. These are my sources.